All right, I believe we are live. Welcome, everyone. This is our free lesson, pre-algebra. We'll be talking about radicals today. I'm going to introduce myself really quick, but want to make sure you all can hear me in the chat. Give me a plus in the chat if you can hear me. That would be great. Does my mic sound okay? Want to make sure that everyone can hear me all right. Hey, Ahmed, welcome to the stream. Welcome to the free lesson today on pre-algebra. Good afternoon. Hi, Stone. Welcome, welcome. Nice to meet you on this Thanksgiving break week. Love to be here. Excited for today's lesson. Excited to make radicals easier for you today. All right, but before we get started, let me introduce myself really quick. Here we go. I'm Eddie. I'm the senior math teacher here at My Ed Space in the US. I've been teaching for 9 years in high schools, colleges. I've private tutored every grade level from 6th grade all the way to students in college preparing for graduate school. So I know exactly how you in pre-algebra, everything you learn is going to affect you in future courses. I'm here to help you to build a solid foundation. That's the most important part about pre-algebra. It's where everything begins. It's where we build that foundation. If we start to build on top of a weak foundation, then everything's going to crumble in the end or eventually. That's why I'm here to help you build that solid foundation so we can continue to build on top of that in years to come as well. I believe in 3 things during my live lessons. I believe in having fun because when we have fun, we tend to remember things better. So I'll try to bring that energy today. I get that energy and I feed off of your energy in the chat as well. So that brings me to my second goal is I want you to make mistakes. Be comfortable with making mistakes in the chat because without making mistakes and fixing them, you're not truly learning and retaining that information. Otherwise, if you already know everything, then, maybe you're filling in the gaps or reinforcing some skills, but make sure to participate, make those mistakes so we have chances to fix them and learn. And third, ask questions. Ask questions. And not just, I'm confused, or how did you do that? But practice asking specific questions on, let's say, for example, on the second step, how did you get from, +4 to -4, things like that, and you'll be ready to go. So without further ado, let's get started. Here's a little vibe check. In the chat, comment an example of a perfect square. An example of a perfect square. If you don't know, you could put IDK in the chat. I respect your honesty if you don't know. But if you do know, give me an example of a perfect square in the chat. Excited to see what we see here in the chat. If you don't know, you could put IDK. I'll make sure to help you understand this today as well. This is one of the fundamental things we need to know in order to access today's work. Mariama, nice. 25? Yes, 25 is a perfect square. Great start. Mariama got us started. Amazing. 25 is a perfect square. It's a perfect square because 25 is equal to 5 times 5. A number times itself is what we call a perfect square. You can think about it like the shape of a square as well. When we have a square, what's the area of this square? Well, whatever the side length is, we can take that side and square it. 1 is also a perfect square. Great. 1 is also 1 times 1. A number times itself. 1 is a perfect square. We have a whole bunch. We have 4, 9, 16. We got 25 already. 36, 49. We got 144 when we keep going, right? We have a whole bunch of perfect squares, infinitely many. And this knowledge is going to be crucial for us. So thanks for getting us started. 0. Is 0 a perfect square? That is a great question. 0, unfortunately, I wouldn't call a perfect square just because you cannot have the shape of a square with 0 as one of the distances. But I really love how we're thinking here. I love that question. That's actually a beautiful question. I will have to get back to you for a more correct answer or more confident answer. But for now, I would assume that 0 is not a perfect square just because you cannot draw a square with 0 as one of the lengths. Beautiful work. All right, I'm excited. We're off to a great start. Let's keep going here. So APK, I love to start off my lessons with something called an APK. It stands for accessing prior knowledge. So every lesson, I try to start off with something that you already know so that you have an opportunity to enter the lesson. And throughout the lesson, we're going to move as a pack together. I'm going to be pushing and guiding you from the back, but there will be some folks, some students in the front leading the way as well. So you have a lot of help in the chat throughout every live lesson, and it's so fire in the chat every time. It's so hype. Everyone's so excited. Let's get into this APK. Simplify the square root of 4 times the square root of 4. Now, I may have said something that you may never have heard before. This little symbol we call the square root because it is the inverse operation of something squared. We also call it a radical, and we also call it just the root. Let's take a look. So simplify each root first. So the square root of 4. In the chat, let me know, what is the square root of 4? Again, we're starting off very simple, right? We're starting off very simple, and as we get to the end of the lesson, that's when we get to the more challenging problems that we can prove to ourselves that we actually understand and mastered this concept of radicals today. So we have simplifying each root, the square root of 4. What does the square root of 4 equal? Meaning, what number times itself gives us 4? What number times itself gives us whatever is within that radical or square root or root? And that's what we're asking ourselves here. And in the chat, don't be afraid to be wrong. I love when students make mistakes, when students have different answers in the chat. That's what really drives the lessons. And you'll notice right away when you join my pre-calculus course, I get tons of messages throughout the live chat, throughout the course of a lesson. And students are unafraid of putting in different answers because they know that, when you make a mistake, it doesn't matter. When you fix it, that's when you learn. So they're giving themselves an opportunity. 2, great, Mariama. Great, great, great. So the square root of 4 is 2 because we know 2 times 2 is equal to 4. Now we have 2 of these, radical 4 times radical 4. So if we put those 2 together, we know that the square root of 4 is 2, multiplied by another 2, we get 4. Now, whenever we have a square root times another square root, we can multiply whatever is within each of those square roots. So the square root of 4 times the square root of 4 is equal to the square root of 4 times 4 because the roots are the same. Because the roots are the same. So now we have the square root of 4 times 4, which is 16. And now we ask ourselves, what number times itself gives us 16? In the chat, let me know. What number times itself gives me 16? And don't be shy. For those of you who haven't commented yet in the chat, feel free, join on in. 4 times 4 is 16. So what number times itself will give us 16 is the question here. The square root of 16 would then equal, since we already know, the same number times itself, or a number times itself is equal to a perfect square. We know here we will have just a 4. Nice, Karina. Welcome, welcome, welcome. Great work. All right, let's keep it moving then. Again, if you have any questions throughout the lesson, I'm constantly looking at the chat. So feel free, ask any questions throughout, and I'll make sure to answer them. Let's lock in, stay locked in, and keep going here. So we're going to do the same thing, but with different numbers. Don't be scared. We're doing the exact same thing. We're going to follow the same patterns that we've observed and investigated and discovered in our previous slide. Simplify the square root of 16 times the square root of 25 by simplifying each root first. So we're going to evaluate each of these roots first. So the square root of 16. Hi, Elijah. Welcome. The square root of 16, what would that be? What number times itself gives us 16? And then my next question would be, what number times itself gives us 25? In the chat, let me know. The square root of 16 equals, and the square root of 25 equals. Awesome. I'm seeing some answers here. Great. I see Karina answered both. Awesome. Beautiful work. That's a 4 for 16 because 4 times 4 is 16. And for 25, we have 5 times 5 is 25. Great, Elijah. You've seen this before, so that's awesome. 4 and 5. So now if we rewrite radical 16 times radical 25, we know radical 16 is 4 and radical 25 is 5. Don't forget, we are multiplying these two numbers, so we have 20 as our final answer. Let's see if we get that same thing when we multiply in root form first. So letter B, we have radical 16 times radical 25. So here we are going to multiply whatever's within each of these square roots together first before we take that square root. So we have 16 times 25. Let's think about this for a second. 16 times 25. Well, we know 4 25s makes 100 because we're good with money, right? 25 cents times 4 quarters equals to $1, which is 100. Well, 4 4s go into 16. So we know that 16 times 25 will be 400. It's like if you have 16 quarters, you have $4. So 400. What number times itself gives us 400? Well, we've already solved it the other way. We know that 20 times 20 is equal to 400. And 400 again, as we saw in our vibe check, we call this a perfect square because a number times itself equals 400. Okay, now let's wrap this up and get a general solution so that we can access the following problems, more challenging problems. Using your understanding from previous question to simplify radical A times radical B. How would you simplify this? In the chat. And when you're chatting the square roots, feel free to just write SQRT, parentheses, and whatever you want within those parentheses. SQRT stands for skirt or square root. So what would you say this would be? The square root of A times the square root of B. How would we write this as one square root? So in the chat, you'd be typing skirt, parentheses, and whatever you think goes within those parentheses when we put these two together. Great. I see Mariama has an answer. Awesome. Don't know if it's correct yet, by the way. I'm just proud that, and I respect that you have an answer. You're being brave, advocating for yourself, speaking up. We love that energy. Gonna wait for a couple more seconds to see if anyone else has an answer, just to give everyone an opportunity to make mistakes, have your voice heard. We have radical A times radical B. Well, we can multiply whatever's within those square roots together to get A times B, and that's what you would have written in the chat. Great stuff. Now, how about this next one? The square root of A times the square root of A. We have A times A. We could do this a couple ways, but the best way to do it would be the way that we did in part A. We'll have A times A. Again, for those of you who may not be familiar with this multiplication symbol, X as a times multiplication symbol turns into a dot later on as we move higher in mathematics, because a dot it doesn't look like the variable X later on. So we use that dot instead. A times A is A squared. And we know that the square root of something squared, those are inverse operations. They undo one another. So here we're just left with A. Okay. Again, if you have any questions throughout, ask in the chat. I will try to answer it right away. Let's keep moving forward. So let's solve some problems. Find the square root of 2 times the square root of 2. What would this be in the chat? Let me know. The square root of 2 times the square root of 2. If I were to simplify this step by step here while you're typing in your answer in the chat, I would say, well, since we have the square root times another square root, we can multiply whatever's in those square roots first. So I have 2 times a 2. Well, that's just 4. And we know from our vibe check of perfect squares, defining some perfect squares, we know that what number times itself gives us that 4? What number times itself gives us that 4? For those of you just joining, don't be shy. Feel free to participate. We love... Wow, Mario, you found the square root symbol. Amazing. Amazing. Love that. Using our tools and resources correctly here, I see. Great stuff. The square root of 4 would be, this one's pretty simple, it will just be 2, because 2 times itself is 4. So whenever we have the square root, again, just for those of you that may be joining right now, whenever we have the square root of something, we're asking ourselves, what number times itself gives us whatever's in that box, right? That's what we're asking ourselves each time. So again, for letter B, we have the square root of 5 times 5. Well, that's the square root of 25. And 25 we know is a perfect square. What number times itself gives us 25? Well, that number is just 5. How about this next one? Can y'all help me with this next one? The square root of 2 times the square root of 3. I'm going to rewrite this. And I have 2 times 3. What number times itself gives us 6? What number times itself gives us 6? We're thinking, well, we know 1 times 1 is 1. 2 times 2 is 4. And then 3 times 3 is 9. So then I'm thinking, wait, 2 times 2 is 4. 3 times 3 is 9. 6 is in between 4 and 9. So, could it be 2? Could it be 3? It's neither, right? Because remember, whatever we have within the radical, Karina, I love the effort in the chat here. Respect that. We don't have any number times itself that will give us a 6. 6 is not a perfect square. So that's our final answer. We leave it as the square root of 6, and we're done. Okay? With that information, let's try these next 3. Okay, with that information, let's take that information and try these next 3. 2 radical 3 times radical 3. Now notice, this 2 is outside of the square root. So if we were to rewrite this, we can rewrite this as 2 times the square root of 3 times the square root of 3. So now we have 2 times the square root of 3 times 3, which is 2 times the square root of 9. So now in the chat, let me know. What is the square root of 9? What number times itself gives us 9? Wow, so welcoming in the chat. I love to see that. Great, Mariama. 3. So since the square root of 9 is 3, great, Karina. Wow, we are on point now. 2 times 3 gives us 6. And that's our final answer. So without doing much math here for this next one, let me know what you get for letter B. Let me know what you get in the chat for letter B. We have 3 radical 6 times 2 radical 6. We know that we can separate the coefficients. Coefficients meaning the number in front of some function. In this case, the square root function. We can multiply those separately and then solve the radicals separately as well. We know that 6 is not a perfect square, so we do have to work with that a little bit. And let me start it off now that I gave you a little bit of a head start. We have 3 times 2. That gives us 6. And then in green, we'll have the square root of 6 times the square root of 6. That gives us the square root of 6 times 6. Well, 6 times 6 is 36. So here we'll have the square root of 36 and times that blue 6. And this is all equal to. Oh, that's a different shade of blue. All good. Now, what's the square root of 36? 36 is a perfect square. What number times itself gives us 36? Well, it's just a 6. So 6 times 6 is 36. And that would be our final answer. Also, if I'm going too fast, let me know. I can slow down as well. But right now, I feel like I'm going at a decent pace. If you want me to speed it up a little bit as well, feel free to ask. But I do try to go at a pace where I believe that every student in my courses can keep up. Let's try this next one. I'll use the same color coding here. Let me use the darker blue here. 3 times 4. That gives us 12. And then 5 times 11. That gives us the square root of 55. Now, in the chat, yes or no, can I simplify this any further? Can I simplify 12 radical 55 any further? Yes or no? 55. Do we know a number times itself, so two of the same number multiplied together? Hey, Joel, can we get 55? Yes, 5 times 11 is 55, but 5 and 11 aren't the same number, right? We want to think about, is there a number times itself? A number squared that will give us 55. Or does 55 have any factors that are perfect squares? No, right? 5 and 11 are both prime numbers. Their only factors are themselves and 1. So this is it. Yes, Karina, no. There's no more that we can do here. Okay, before we move on, put a W in the chat if you feel like you're slowly starting to understand this or you already know this. Put a plus in the chat if you feel like you're getting there little by little, but you do need a little bit more practice, which is what we're about to get right now. So a W if you understand this or you've seen this before. A plus if you're slowly getting there, but you know you'll get there eventually. It's all about that growth mindset. It's not that you don't know it, it's that you don't know it yet. And we're going to get you there today. Awesome. I see both a pluses and W's in the chat. Love to see it. That's a perfect place to be. Let's get it. Sometimes radicals are not in their simplest form, so we want to simplify the following radicals. Letter A says the square root of 8. And now when we think about the square root of 8, we're thinking about, is there any number times itself that gives us 8? Well, let's list all the perfect squares that we know. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Well, 8 is right in between 4 and 9. So we know the answer to our question. Is there a number multiplied times itself that gives us 8? The answer is no. But we don't stop there because 8 has a factor that is a perfect square. Let's look at our perfect squares again. We have 1, 4, and 9. Well, 9 is not going to be a factor because it's greater than 8. But is 4 a factor of 8? 4 is a perfect square. 4 is a perfect square, and it is a factor of 8. And what I mean by factor, if you've never heard that term before, a factor of a number means that number is divisible by the factor. So 8 is divisible by 4. And we get 8 is equal to 4 times 2. So we're going to go backwards now. We're going to go in reverse. Great, Joel. So we have the square root of 4 times the square root of 2. Previously, we used to put the square roots together. But since they are equal, since these two things are equal, I can go in the opposite direction as well. So I can split these up as the square root of 4 times the square root of 2 as well. It goes both ways. Now the square root of 4 is 2 because 2 times 2, or 2 times itself, is 4. So this radical 4 turns into a 2. This radical 2 stays the same because we don't know a number multiplied times itself that gives us a 2. And now we've completely simplified. Okay, we're going to keep going here with letter B. If you didn't understand letter A, all good. Letter B is very, very similar. Now, 50 is much bigger than 9, so let's keep going. 4 times 4 is 16. Not close to 50 yet. 5 times 5 is 25. Halfway there. 6 times 6, 36. Almost there. 7 times 7 is 49. Awfully close, but not quite 50. And then 8 times 8 jumps up to 64. So again, no number that multiplied times itself giving us 50. So let's write it down as a product of two numbers. Is there a perfect square that will be a factor of this 50? Mariama, great question. Do you remember all the squares? The more you work with these, the more familiar you'll get with them. The more you work with these, the more familiar you get with them. But I recommend that you know at least the first 15 squares. So 8 times 8, 64. Then 9 times 9, 81. Let's write them all down, actually. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196. And then 15 times 15, 225. So you should know at least up to the first 15. In my opinion, it'll be very, very useful. And I'll show you a little trick in a little bit. So 50 is actually 25 times 2. 25 is a perfect square. And the square root of 25 is 5 radical 2. Now, let's check out letter C. Radical 300. Before we even look at 300, what do you know is a factor of 300 that will be a perfect square? A perfect square factor of 300 in the chat. Just look at the number and think about, is there a perfect square that's really nice that's going to be a factor of 300, or that is a factor of 300? Great, Mariama. Great. 100, right? 300 is 3 times 100, or 100 times 3. So I can separate these. And the square root of 100, well, we know 100 is right here. 10 times 10 is 100. So we have 10 square root of 3. Okay, let's check out one more. Letter D. The square root of 32. Oh, with 3 in the front as well. Don't forget that. So we have 3 times the square root of what two numbers where one of the numbers is a perfect square equals 32. What two numbers, what product of two numbers where one of them is a perfect square equals 32? Let's see, 32. 16. We have a 16 times 2. So 16 times 2 is 32. And now we can separate all these square roots. The square root of 16 is 4. So we have 3 times 4 times the square root of 2. And so we have 12 radical 2, just like this. Okay, let's do another temperature check here. W's in the chat if you're starting to get it or you fully understand it. And pluses in the chat if you feel a little bit lost and you have a question. Here's your chance to also ask that question after you put either a W or a plus in the chat. Even if you're at a W and you put a W in the chat, let me know if you do have a question. Oh, I love to see it, Karina. You were at a plus earlier. Now you're at multiple W's. Love that enthusiasm, Joel and Mariama as well. Beautiful. Awesome. Let's bump up the level then. Now that we're a little more confident, let's challenge ourselves and become even that much more confident. Here we go. Simplify the following radicals. Now, don't get intimidated because we're going to do the same thing. Okay, we're never going to make too big of a jump. We're going to do the same thing. We'll do it step by step, and let's try this out. Letter A. We have the square root of 75 minus the square root of 27. Let's work with each one by itself because this time, notice, we do not have a multiplication symbol between these radicals. So we have to work with them separately. Okay, let's work with 75 first. In the chat, let me know a product. Okay, wow, Joel got it before me. Great. 75 is 25 times 3. Amazing work. Now, how about for the 27? Similarly, how can we rewrite 27 in product form as a multiplication of two numbers where one of the numbers is a perfect square? How can we rewrite 27 as a product of numbers, product of two numbers where one of them is a perfect square? Like we did with 75. 75 is a product of two numbers, 25 and 3, where one of them, the 25, is a perfect square. Great, Mariama. 3 times 9. So 9 times 3, perfect work. Now, let's simplify each of these square roots. Now, the square root of 25 is 5. 3 stays within the radical. The square root of 9 is 3. The other 3 stays within the radical. So if I were to color code these, the square root of 25 is equal to 5. The square root of 9 is equal to 3. And notice the 3 still stays within the radical. 3 still stays within the radical. Okay, that's kind of how we color code it. Now, notice something really, really neat happens here. Both of these terms have a square root of 3. So if you have 5 of something, and you subtract 3 of that same thing, we're now left with 2 of that thing. right? We have 5 radical 3's, and we're subtracting 3 of them. So we're left with 2 of them, and we're done. That's it. The square root of 75 minus the square root of 27 is 2 radical 3. This is not equal to the square root of 48. That does not work. Okay, you cannot work outside of the radical until you've simplified everything within the radical. Okay, keep that in mind, especially when we are adding or subtracting radicals. Let's try out letter B. Square root of 20 plus the square root of 45. How would you rewrite 20? In the chat, let me know. How would you rewrite 20 as a product of 2 terms where one of the terms is a perfect square? And then after that, let me know for 45 as well. What 2 numbers multiply to 45 where one of them is a perfect square? We have 20 and 45. 10 and 2. All right, let's check out 10 and 2. Between 10 and 2, are either of these a perfect square? Well, 2 definitely not, because it's prime number. It's only divisible by 2 and itself, or sorry, 1 and itself. 10, 3 times 3 is 9, and 4 times 4 is 16. 10 is right in somewhere in the middle here. So unfortunately, 10 is not a perfect square. So we need to find 2 different numbers where one of them is a perfect square that multiply to 20. Let's keep thinking here. Again, we love that we're trying, right? We love that we're attempting, because we're giving ourselves an opportunity to make mistakes or get things wrong, because when we fix them, that's when it clicks, that's when we learn, that's when we continue to build that solid foundation, which is so important in pre-algebra. And this is why you need to know your multiplication tables to work with higher level things like this. The square root of 20, let me help you out here, is 4 times 5. 4 is our perfect square. 4, the square root of 4 is 2. So this becomes 2 square root of 5. 5 is a prime number. We cannot take the square root of it. Now let's take a look at 45. 45 would be 9 times 5. The square root of 9 is 3. And now we have 2 of something plus 3 of that same thing. In total, we have 5 of them. Don't forget to bring that thing down as well. Okay, I want to get a quick check here. W's if all this is making sense so far, but you still need a little bit of help to get through it. Pluses if you're feeling a little lost in the chat. And I'll try to explain it one more time if I do see any pluses in the chat. And while you chat that, W or plus, we're just taking each of these numbers within the radicals and finding a product of 2 numbers that multiplies to that number that we had before. Great, Mariama. W's. Love the W's. Okay, let's keep moving here. Don't be afraid to ask questions whenever you have one. Whenever it pops up, that's the great thing about these live lessons, by the way. Whenever a question pops up in your mind while doing these problems, ask it, just type it right in the chat, right? You won't be disrupting the lesson at all, because I'm still going to go with the problem. And eventually when I look back at the chat, I check maybe every 5 to 10 seconds. So I'll see it. And if it's relevant to that step, I'll answer it right away. But if it feels like it's not as relevant and I can answer it later, I'll for sure get to it eventually. So let's check out letter C. 2 square root of 1,000 minus 5 square roots of 40. Let's take a look at 1,000. Well, 1,000 is 100 times 10. 40 is 4 times 10. So now, the square root of 100 is 10. So if I were to color code this, the square root of 100 is 10. Now, for this next one, we have minus 5 times, again, we have the square root of 10 here, and the square root of 4 is 2. So now let's distribute. 2 times 10 is 20. The radical 10 is there. Minus 5 times 2 is 10. The square root of 10 is still there. Now we have 20 of something, 20 radical 10s, and we're subtracting 10 of them from that 20. Then we're left with 10 of them. Kind of nice how this works out, right? 10 and 10, one on the outside, one on the inside of the square root. That was intentional, just to make it look nice. Letter D. Let's check out this last one on this slide. 6 radical 175 plus 2 radical 28. Ooh, I just remembered. I forgot to mention at the beginning of the lesson. For those of you that are new here, there's a workbook in the description below of this video. In the description, you'll see that very first link. That's a workbook that you can use and print out before the lesson so that you can access every single problem that we'll be covering in that lesson. All right, so you don't have to copy down any of the problems. You don't have to be anxious about what's coming up. You know exactly what the lesson is going to cover before the lesson starts. All right, so the square root of 175. 175 is divisible by 25, so I'm going to write that down first. And 175 in terms of money would be 7 quarters. So I know that's 25 times 7. Plus 2 square root of 28 is 4 times 7. So now let's simplify. We have 6 times 5 radical 7 plus 2 times 2 radical 7. Now we have 30 radical 7 plus 4 radical 7. If we have 30 of something plus an additional 4, we have 34 radical 7. Now we're about to jump up a level again. We're about to bump it up a level. In the chat, let me know. I still want to know, are you guys still at W's or are some of you at pluses? Be honest with yourself. It does not impact your grade, does not impact anything except for your learning. W's in the chat if you're getting this, or you feel like if I gave you a practice problem, you'd be able to get through it on your own. Pluses in the chat if you have some questions and you'd like to ask. Nice, multiple W's from Karina. Love to see it. Love to see it. Okay. I'm going to assume that we're good to go. But if you do have a question, if you're here and you have a question, feel free, ask those questions. Let's keep it going. All right, simplify the following radicals here. We have this 4 square root of 6 times 2 square root of 10. Okay, so for these, I'm going to multiply the 4 and 2 first. That gives me an 8. And now since we're multiplying, I can multiply whatever were inside the square roots, inside the radicals. And 6 times 10 is 60. So I have 8 radical 60. And now it becomes a much simpler problem. 60 is easy to work with. 60 is simply 4 times 15. So again, this comes back to our multiplication tables. We need to be comfortable with those. Test yourself with them if you're struggling with them. Just like think of 2 random numbers, preferably smaller than 20, and just do it in your head, right? Like 3 times 17. What is that going to be? 51, right? Things like that. So practice on your own. 2 random numbers. Work it out. Check it on your calculator, and that's how you get better. Practice. So radical 4 is 2. So 8 times 2, radical 15. So we have 16 radical 15, and we're donezo. Let's check out letter B. 5 radical 10 times 2 radical 20. Now, I'm going to simplify this first part. 5 times 2 is 10, and now we have 200 within the radical. In the chat, let me know, what would you split 200 into? What 2 numbers would you split 200 into? What number times another number gives me 200, where one of them is a perfect square? Where one of the factors is a perfect square, what would you split 200 into? What 2 numbers? 200. I'm thinking, well, we can always start small, by the way. If you were to have some strategy to this, always start small. Don't start with 1, because you know that 1 times anything is going to be that anything, right? Anything times 1 is itself. So let's start with 2. We have 2 times 100 is 200. And we think to ourselves, oh, 100 is a perfect square. Let's use that. So we have 100 times 2. So the square root of 100 is 10 times the square root of 2. So now we have 100 square root of 2. All right, let's try letter C. Letter C says 2 square root of 12 times 3 radical 18. Now this one might be a bit tougher. This one, we would have 6 square root of 12 times 18. But that's going to give us a fairly larger number. So instead of doing it this way, I can go about it a different way. I can choose to simplify 12 and 18 first. So I have 2 square root of 4 times 3 plus 3 times the square root of 9 times 2. So that gives me, oh, oops, this is multiplied, right? I put a plus because we were so used to adding it up in our previous slide. So the square root of 4 is 2. 2 times 2 is 4. So we have 4 square root of 3 times. The square root of 9 is 3. So 3 times 3 is 9. Square root of 2. I'll put the little 2 up here as well. Okay, now we multiply. 9 times 4 is 36. 3 times 2 is 6. And we're done. And this is multiplying with radicals, simplifying radicals. So we've talked about addition, subtraction, multiplication with radicals, and we've also talked about simplifying these radicals into their simplest form. Simplest form. This is our very last problem set here. Let's see if we can get these. Whenever we have parentheses, we must distribute. Another word for expand means to distribute. Okay, distribute, expand. Some people also call it unfactor, because when we factor, we're splitting things up, but when we unfactor, we put everything together. Great, Isabel. Welcome. So we're going to multiply radical 3 times 1 and then radical 3 times radical 3. Let's write down every step to start. We have radical 3 times 1 plus radical 3 times radical 3. So anything times 1 is itself. So Isabel started off correctly with this root 3. Plus, we have root 3 times root 3. There are a couple of ways to write this, by the way. We haven't been doing it like this just yet, but let me show you a different way to do this. We've been doing it like this so far. And this gives us root 9, which is equal to 3. However, another way to write this is that whenever something times itself is written, we can rewrite it as that thing squared. And we know that the square root and the squared undo one another, and that'll just leave us with whatever's inside that square root. So that's exactly what happens right here. All right, let's try letter B. Again, we're going to do the same thing. Distribute this to both terms within the parentheses. So we have 2 radical 7 times a 3 plus 2 radical 7 times another 2 radical 7. Ooh, this one's going to be interesting. So 3 times 2 is 6. So we have 6 radical 7 plus, we have 2 times 2, which is 4, times radical 7 times radical 7. Well, that's just radical 7 squared. And that gives us 4 times 7, which is 28. Let's try this last one together. For these, we have to be very careful to make sure to distribute every single term with one another. Radical 5 to 3, radical 5 to negative radical 5. So this first one, we get 3 radical 5. And let me know in the chat really quick, what is radical 5 times radical 5? What is radical 5 times a radical 5 going to give us? And then the other ones here will be a plus 6 and a minus 2 radical 5. A radical 5 times a radical 5 can be rewritten as that radical 5 squared. And we know that when we square a square root, they undo one another. So we'll have just a minus 5. This minus must come down as well. Plus the 6. And we have 3 radical 5 minus 2 radical 5. That's just radical 5. Minus 5 plus 6 is 1. So we have 1 plus radical 5 as our final answer. Okay, now here is the best part. If you enjoyed today's lesson, or if you learned something new today, or if today's class helped in any way, put a W in the chat right now. Put a W in the chat if today's class helped, if you learned something new, even one thing new. And if you enjoyed it, any one of those, put a W in the chat. Awesome. I see Mariama enjoyed it. W's all around. W stream, W engagement. Korean said W for sure. Awesome. Now, today was just one piece of pre-algebra. Today, we covered the 5th module in our November module, radicals. And you can see that we are going all the way through the month of May to June 5th. This is the curriculum that I have planned out for pre-algebra. It meets national curriculum standards as well. And now, if you enjoyed it, this is your opportunity. Try my EddSpace for 7 days for just $7. You get full access to the next week, the next 7 days, and you can cancel anytime. And when you join, this is what you get. 2 engaging live interactive lessons per week, just like you got today. So 2 of these per week. You have video recordings to revisit every lesson. So even now, this lesson right now is being recorded. It'll be uploaded to our platform, and you'll be able to review it at any time, right? Let's say you go over radicals later in the year. You want to come back to this, you can view it right away, right? Every lesson is recorded. You can review it at any time. Or if there was just one part of the lesson that you wanted to revisit, go ahead. As soon as the stream ends, you can go right back and view that as many times as you'd like. Furthermore, you get these workbooks, professionally designed lesson materials that you get to use throughout the lesson, so you don't have to write down every single problem on a separate sheet of paper. You have it right there in your workbook to solve out, so you don't have to jot down anything that's already on the slides when we start. After every lesson, you'll get a unique set of practice problems that consolidates all the learning from that lesson, and you'll be able to truly assess whether you've mastered that material. But don't worry if you get these practice problems wrong, because I have already filmed and recorded video solutions step by step, going through every problem on those practice problems, so that you have full help and guidance on every single problem that you practice as well on our platform. We have hundreds of 5-star reviews, so don't just hear it from me, hear from all of these people. For example, 100 out of 10 from Saber, like Chowdhury, Sam, Faizan. So many reviews, hundreds of 5-star reviews. So families around the world, 17,000 students helped already. Yeah, quite an impact that we've made already. So if you'd like to join, grab your parents for 60 seconds. This is not a sales pitch. This is just so that we need their approval, right? We need your parents' approval to get you into my EddSpace. So call them over. It'll just take 60 seconds. And here we go. Hey parents, your child just finished a free lesson and wants to try it out for 7 days. So it's $7 for 7 days, and you get your money back, and you can cancel with one click. So it's risk-free, right? Completely risk-free. After the 7-day trial, you can get every month for just $149 a month. That's 8 lessons a month, 7 to 8 lessons a month for just $149 for that month. For $7, you get all of these, right? 2 interactive lessons per week, just like the one that we had today. It's fully recorded so that you can revisit them at any time. You get workbooks where you can follow along in the lesson as we go. You get practice problems after these as well, where you get immediate feedback after you complete those practice problems. You know exactly how you did. And for any questions that you may have a question on, maybe you guessed on it, got it correct, I have those video solutions that work out the problem step by step. Here's the lesson schedule for pre-algebra. We meet Mondays and Wednesdays at 5 p.m. Pacific time. Each lesson is 55 minutes, just like the one you saw today. So again, Mondays and Wednesdays, 5 p.m. Pacific time. However, reminder that all the lessons are recorded. So even if you cannot join live, you can still access the recordings at any time on our platform, everywhere, literally from anywhere, okay? And to protect you from any risk, like I mentioned, we provide a full refund guarantee, no risk involved. So if you'd like to start, scan this QR code to get you started with our 7-day math pass. If the QR code is not working, you can also go to myeddspace.com/7. And I'm excited to see you join my EddSpace and start your journey with me. So if you plan on joining that 7-day trial, put a W in the chat. We'll love to see that. And right now, I'll put that link up as well, myedspace.com/7. You can check out that link, and that'll take you where you need to go. Awesome, Karina. I'll see you, and you're gonna feel the vibes in our course as well. I mean, all the families and students that have already joined our course, they love it. They're finally having fun in math. They're saying that they're doing better in school. Parents are saying that their student is much more confident, like feeling more confident. They can see it, right? They're seeing the improvement come to fruition now that we're, a couple months, like months into the course. They're seeing the fruit, right? They're seeing improvement. They're seeing their grades go up. Really, really exciting for me to hear as well, because that means, I know it's working, right? I've been teaching for 9 years. I would hope that it works, and it is working. So really, really excited to see that. If you have any questions, I'll stay on for another minute or so to answer any of those to the best of my ability. But again, scan the QR code to start, or go to myedspace.com/7 to get started with your 7-day math pass. And join me next week, starting on Monday. We meet Mondays, Wednesdays, 5 p.m. Pacific time. All right. Well, if you have any questions, feel free to reach out or put it in the chat, and I will see y'all soon. 6, 7 days, 6, 7. Yeah, around like 6, 7 days. All right. Thank you for joining in today. I will see you when you start your journey with me at My Ed Space. Have a happy rest of your day. Bye-bye.